Hi Apes, today we're taking a look at Unit 6, Part 6. We're going to focus on water, geothermal, and fuel cells to wrap up our renewable energy sources. So I want to start off with water. Now we can look at water in a couple of different ways. We can look at it with dams, we can look at it with tide power, and wave power. So we'll look at the dams in just a second. That's your more traditional form of hydropower. But also we can take a look at the perpetual motion of waves. If you can connect some type of a generator to a turbine that floats in the waves, that can create just constant energy. You can also create some type of a coastal system that allows waves to rush into a chamber and displace air that turns a turbine. And the air can also just be displaced coming out, so you can have a constant motion of a turbine. But another way we can take a look at it is the constant and reliable movement of tides.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
So like she said, tidal power doesn't work everywhere. It has to be along the coastline, and you do have to have a pretty significant tidal range. But one area where we do have a lot of potential is our traditional dams that dam up a river. So we're going to take a look at how this flows, but just to kind of give you a sense, here is our upstream of the dam. Now that's going to be important to understand upstream and downstream terms. So upstream of the dam, so our dam is flowing down to the right. So this is upstream, and this forms a reservoir, and then this is going to be potential energy. And as the water is allowed to flow through the channel, that's kinetic energy or movement energy, and then it turns a turbine, that's mechanical, and then it gets converted to our electrical energy in the generator. So those are our different forms of energy. So this is upstream of the dam, and this is downstream.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are 2 main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
Okay, so they did a pretty good job of going over the pros and cons. So one of the biggest ones is that it is abundant. There's lots of sources for it, and it is clean. And again, when I say clean, I mean that there's no CO2, no SOx, no NOx, no particulate matter when the use of it. So that is important to understand, that it is the use part, because as she said, the construction of the dam is going to require a lot of fossil fuels. But the use of that power, the production of electricity, is very clean. Now, some of the pros of dams is that, in one, it can control downstream flooding. So you can make sure that you moderate the amount of water coming downstream from the dam. And upstream of the dam, you create a reservoir, and that reservoir has a lot of uses. So what you can use that reservoir for is you can use it for recreation, you can use it for fishing and boating. The dam itself and the management of that reservoir will create jobs. It will create an environment for water for agriculture and drinking water. So you can have a reliable source of water up there. So those are all some of our pros of dams. But some of the disadvantage is that there is a harm to fish. If I have a river flowing, and let's say that it's flowing this way, and I build a dam right here. Now upstream of the dam, where it once was a river, now it's going to become a lake. Okay, so that is a huge loss of habitat for this coastline area. Now downstream of the dam, I once had a river, and now I'm going to have just a very small river. Okay, so I've lost all of this river habitat. So that's going to have a big impact on fish. Now, if I'm a fish and I'm trying to swim upstream, I'm not going to be able to make it past the dam. So it's going to block that migration path. Now, one way around this is that there are things that are called fish ladders that are essentially an alternative pathway. Now, these are man-made and these are man-managed. So they kind of make them jump up like steps of a ladder to go around the dam and get back up there. And so that is one way around on some dams that they can build fish ladders, or there's also even work on what's called a fish cannon, where they load fish into a tube and shoot them up and over the dam. But the dams definitely can be harmful to fish. Water coming out at high pressure can have bubbles that can harm them. Small little fish that are upstream of the dam might get caught in the turbines and killed. So there definitely are some impacts on fish. There's definitely loss of habitat both upstream in the form of flooding and downstream in the form of that river is now no longer what it once was. It's much smaller, so you've lost your river habitat. So there definitely are pros and cons, but it is a clean, relatively reliable source of energy. Now, geothermal is another form of energy that is very site-specific. Geothermal, what this essentially means is heat from the earth. And so this is going to be very dependent on where you are. Now, Iceland is very big in geothermal because they sit right on a plate boundary. They're on a divergent boundary. And so you'll see this most often if you have countries that are in close relation to our plate boundaries with plate tectonics. So on a large scale, what we look at with geothermal is we use heated groundwater. So if this diagram is for a large-scale power plant, we have our heated groundwater down here that we pump up and we pressurize. And that creates steam used to turn a turbine connected to a generator. Now, groundwater, if you remember, takes a very, very long time to recharge, so we don't want to use up our groundwater. So this is a cooling tower that puts in cool water to condense that steam back to groundwater or back to water, and then we pump it back down underground to get heated up again. So it's a non-consumptive use of that groundwater. So if you'll notice, this is the same method that we're using always to make electricity. We're finding a way to make steam to turn a turbine connected to a generator. And in this case, we pump that water back down. So that would be a large-scale geothermal power plant, but also we have geothermal heat pumps that you might even have in your own house. So what a geothermal heat pump does is it takes advantage of the insulating property of the ground. So once you get a certain distance under the surface of the soil, your temperature of the soil is going to be very, very standard, somewhere in the upper 50s to low 60s. So you can actually use it as both a heating and a cooling mechanism depending on the season that you're in. So in the summer, if you want it to be on cooling mode, you're going to pull in warm air and pump it underground. So you'll have it in pipes going underground. The heat will be dissipated into the soils, cooling that air off, and then it will come back into your house cooler. So it makes it so you don't have to cool that air as much, say for air conditioning. Now, same thing for a heating mode. If the air is cooler than the soil, you pull in that cool air, pump that underground, the heat will go from the soils to the air, raising that temperature up so your heater doesn't have to work so hard. So it can actually go both ways by taking advantage of that ability of heat to flow from high to low. So we can make things a little bit cheaper to heat and cool either your house for air or water is fine too. So the advantages of geothermal is that there's no air or water pollution. And again, I'm kind of cheating when I do this. So I should say no CO2 or SOx, NOx, particulate matter from the actual use of geothermal energy. But the disadvantages are like some of the others, that it's not possible everywhere because of its site specificity. The setup and maintenance can be pretty expensive, particularly if you're using that groundwater, because that has a lot of minerals in it and can be quite corrosive. So fuel cells is our last form of energy I want to talk about, and fuel cells are something that you might start to see more and more about. We've had a little bit of struggle with them, but with fuel cells, they are incredibly efficient because there's very little conversions. You go straight from your chemical energy right into a flow of electrons or electricity. So we do use traditionally as hydrogen. We use hydrogen and oxygen, and the waste product is water. Now, one of the big cons here is that our main fuel source, hydrogen, is just not readily found. And so the distribution of that right now is a challenge. So where we're seeing the most future for fuel cells is with cars. And you need to have a constant source of hydrogen and we just don't have fueling stations set up like we do for gas stations. So this could be something that's coming in the future, but another thing that fuel cells work really well as is a backup energy source to any of our fuel sources we've talked about here, to solar, wind, and water. So I'll have a short little clip that shows how a hydrogen cell or fuel cell works.
Have you heard about the new sustainable energy technology called fuel cells? In fact, they're really not that new. Fuel cells were invented in 1839 by William Grove and were developed by Pratt & Whitney and other companies in the 1950s. Safe and dependable, they were used by NASA and the Russian space program to power spacecrafts. Today, leading global companies like Apple, Verizon, and Coca-Cola use fuel cells to generate clean power. Honda, Toyota, and other car companies use them to power their new generation of pollution-free cars. So how do fuel cells work? Fuel cells use hydrogen and oxygen in a chemical process to produce electricity and heat. The only byproduct, pure, clean water. A fuel cell has two electrodes, an anode and a cathode, and between them, an electrolyte. The catalyst on the electrode breaks the H2 hydrogen molecules to allow them to combine with hydroxide, OH negative ions, to create water and release electricity. But unlike batteries, fuel cells don't store power for a limited amount of time. They generate it for as long as you have hydrogen. As a source of backup power, fuel cells are much better than diesel generators. They aren't smelly or noisy, and they don't produce harmful exhaust. Fuel cells can be used anywhere you need backup power. Mobile phone towers, electrical substations, manufacturing, and much, much more. Other green power solutions harness the sun or wind. But if you're caught up in a cloudy day or on days where the air stands still, these solutions can leave you without enough power when you actually need it. That's why you need GenCell.
So that did a good job of showing the application and how a fuel cell actually works and some of the uses that we have as a backup, or hopefully at some point as something to run our cars. Now, at the end of the day, what we really need to do is find ways to encourage a shift in mindset of our energy uses. So what I think is going to happen is that it's going to have to be driven by economics. You have to make it more attractive to use the types of energy sources that are sustainable and helpful to the environment, and you have to make it a little bit more expensive to use the ones that are non-sustainable. So the way that we do that is with subsidies. So subsidies are going to lower the purchase price. So those are government funds that help to lower the purchase price. Or you can also do tax breaks. Now tax breaks are done after the fact, and so you might have to pay full purchase price, but then you'll get a rebate on your taxes at the end. So those are definitely ways to encourage the use of these alternative sources of fuel. And another thing what we need to do to encourage just sustainability is improving our electrical grid. There are a lot of problems with it, lots of waste and lots of rooms for improvement. So making the energy that we have more efficient is a great first step.